Dear students, in this topic I am going to discuss about the reflection and refraction of plane waves, and there are different cases, that is a reflection by a perfect dielectric and reflection by a conducting medium. Now let us see that what would be the reflection of the electromagnetic wave when it is passed from one medium to other medium. So here we can see that this is medium 1 and this is medium 2. The medium 1 and medium 2, they have different dielectric permeability constant. So here we can see that mu1 and epsilon 1 is permeability and permittivity of medium 1, and whereas mu2 and epsilon 2 are the permeability and permittivity of medium 2. So EI represent the electromagnetic field intensity of the incident wave. It is directly incident. It is incident normal to the plane. So this is the plane. So this plane is directly distinguishes these two medium. So when it directly incident on this plane, some of this wave reflected back, that is ER. Here we can see that it is a reflected wave, and EI is the incident wave, and some of the waves that will transmit to the other medium. So that means this is a refracted waves. So light is an example of electromagnetic wave. So when light pass through from one medium to other medium, what we can see that some of the light that will reflected, and some other light that will penetrate through the medium. So this is the same cases, but here the electromagnetic wave is incident normal to the plane. And let's see that how we can connect this with the intrinsic constant. So last class we discussed about the intrinsic impedance. It's just like a characteristic impedance of a transmission line, and the same thing, the impedance of the medium, when an electromagnetic propagate through that can be expressed using an eta. So it is electric field intensity, and which is upon the magnetic field intensity. Suppose if it is the characteristic impedance of an incident, then we can represent as EI and HI, where EI is the electric field intensity of the incident wave, and HI is the magnetic field intensity of the incident ray. So this is the characteristic impedance of the medium 1. Similarly, the characteristic impedance of the medium 2 we can write down as, so this is eta so in the medium 2 it is a transmitted wave, so this is ET by HT. Similarly, eta 1 can also be expressed in terms of the refracted, reflected wave, that's ER. So ER by HR. So we know that electromagnetic wave consists of electric field and magnetic field. They are orthogonal to each other. So the transverse component of E and H, this is E and H, they are on XY axis, and Z axis represent the propagation, the direction towards it propagates, the electromagnetic wave is propagating. So the eta represent the intrinsic impedance, which is the ratio of the transverse component of the E and H. And in other way we can represent the eta that we discussed in the last class in terms of the permeability and permittivity. So we can, if it is for medium 1, so eta 1 is mu 1, which is upon epsilon 1. Then eta 2 is mu 2, which is upon epsilon 2. And we are going to use this whole expression to bring about the reflection by a perfect dielectric medium. Now let's see that how we can connect all this together. and before which see EI, which is the incident ray, so which we can write down as EI is eta 1 HI, and similarly ER is, it is a for reflected waves. So we will use minus symbols, because we can see that the direction of incident wave and reflect wave are both are in an opposite direction. So this become minus eta 1 and HR, and the transmitted, that is in the medium 2, so eta 2 and HT. In another way we can represent the HT and ET as HT is the field intensity of incident and the field intensity of reflected. Similarly ET is intensity of incident and intensity of reflected. And now let us use this expression. This is A and this is B. I am going to use expression A here. So HT is HI is EI upon eta 1, and HR is minus ER upon eta 1. So eta 1 we can take it out. So EI minus ER. And also see that what is HT? HT is here, which is ET by eta 2. So what is ET? So ET is EI plus ER. And now we can equate these two expression, C and D we can equate. So C equal to D 1 by eta 1 EI minus ER is equal to 1 by eta 2 EI plus ER. Just cross multiply and rearrange this expression. So eta 2 will go to here and eta 1 come here. So eta 2 EI minus ER, eta 1 EI plus ER multiply eta 2 EI minus eta 2 ER is equal to eta 1 EI plus eta 1 ER, and bring the eta 1 terms to the right and left side, and sorry, the E1 and ER on the right and left side. So eta 2 EI, you can take this to the side, minus eta 1 EI eta 1 ER plus eta 2 ER. So we can take out of EI, eta 2 minus eta 1 equal to ER eta 1 plus eta 2. If you take the ratio of ER, the reflected and the incident, eta 2 minus eta 1, which is upon eta 1 plus eta 2. So this is called a reflection coefficient. A reflection coefficient is the ratio of this reflected field intensity which is upon the incident field intensity. Now let's see what is a transmission coefficient. Transmission coefficient. So which is the ratio of the transmitted field intensity which is upon the incident field intensity. So we can use the previous expression. So what is the transmitted field intensity, which is the sum of incident and reflected. So incident and reflected. If you rearrange this become 1 plus so what is this? This is the reflection coefficient. So if you put the expression of this reflection coefficient here, this one, so it become 1 plus eta 2 minus eta 1 and eta 2 plus eta 1. So this become eta 2 plus eta 1 plus eta 2 minus eta 1 upon eta 2 plus eta 1. So these two get cancelled. So the transmission coefficient ET in terms of the electric field intensity is 2 times eta 2 by eta 2 plus eta 1. So eta 2 and eta 1 are the intrinsic impedance of the medium 1 and 2. So this is the transmission coefficient. Now let us see what is the coefficient in terms of H. These are in terms of E. This is the expression. If you bring the expression of H here, so we can write down as for magnetic field. The above expressions were for the electric field. For magnetic field, HR by HI. So this is the incident magnetic field and this is the reflected magnetic field. So what is HR? So HR is minus ER upon eta 1. Similarly, HI is EI eta 1. So eta 1 get cancelled. So this is minus ER EI. So this is a minus of the reflection coefficient in ER by EI. See this one. So this minus will come. So eta 1 minus eta 2. So this become, since there is a 1 minus here, this become eta 1 minus eta 2 upon eta 2 plus eta 1. Same magnetic field. Let us see what is HT by HI. HT by HI. So what is HT? So AT is theta 2 HT. So HT become Et by theta 2. So hi is ei by theta 1. So this we can represent as eta 1 upon eta 2 times et ei. So we already found the expression of et by ei. So look back. So et by I is 2 theta 2. So this is 2 theta 2 by theta 2 plus theta 1. So theta 2 get cancelled. So this become 2 theta 1 by theta 2 plus theta 1. So this is the coefficient, the refraction coefficient of the magnetic field. Now we are going to do one assumption. Assumption is the approximation is very close. For a perfect dielectric, see this is the dielectric medium 1 and this is another dielectric medium 2. Let us assume that these two are perfect. For a perfect dielectric medium, this mu 1 is mu 2 is equal to mu 0. This is the assumption we are going to use. Mu 1 equal to mu 2 equal to mu 0 because the medium 1 and medium 2 are perfect dielectric. So therefore here will be expressed, so theta 1 is equal to mu by epsilon 1. Now mu 1 become mu 0. Similarly theta 2 also mu 2, so mu 2 become mu 0. Now I am going to use the expression of the reflection coefficient ER and EI, which was 2 minus eta 1 eta 2 plus eta 1. What is eta 2? So mu 0 minus mu 0 mu 0 epsilon 2 plus mu 0 epsilon 1. So we can take out mu 0 because mu 0 is common in numerator and denominator. So 1 by epsilon 1, this become 1 by epsilon 2 and this become 1 by epsilon 1 in square root. So we can minimize. So let us remove this mu 0. Because mu 0 is common. So we can rearrange this one as, so if we take square root of epsilon 1 minus square root of epsilon 2 all divided by square root of epsilon 1 epsilon 2. Similarly on the denominator side, square root of epsilon 1 plus square root of epsilon 2 square root of epsilon 1 and epsilon 2. So these two get cancelled. So the final expression of ER and EI, this is the reflection coefficient in electric field. In terms of permittivity of the medium is similar. Let us see that what is the refraction coefficient. Et EI, which was 2 epsilon 2 2 eta 2 and eta 1 plus eta 2. So this become 2 times mu 0 epsilon 2 mu naught is common in numerator and denominator, so we can remove mu naught, and this become 2 by square root of epsilon 2, and this is epsilon 2 plus epsilon 1, epsilon 2 and epsilon 1. So there is a epsilon 2 common here, so here it get cancelled, so this become finally Et by Ei is 2 square root of epsilon 1 epsilon 2 square root of epsilon 2 square root of epsilon 1. This is the refraction coefficient of the electric field in terms of the permittivity of the two medium 1 and medium 2. If you do the same thing for the reflection coefficient of the magnetic field and reflection coefficient of the magnetic field, we can write it down as HR HI in terms of the permittivity of the medium as if you look these two expression, both are similar, but there is a minus sign will come here. The same minus sign we have seen here. See that this sign is. Similarly, the transmitted coefficient of the magnetic field is also if you look at this, both are identical, but except the numerator term is theta 1 is, but it is theta 2 here. So copy this onto your notebook, and you can expect this question in the university. This is one of the most important question we can expect in the semester exam. Thank you.